All right, now we've got two practice problems on this. They're really, really simple because they go along just from that formula right there. So it says, and this is very, very real, what if you wanted to prepare a 500 milliliter solution of 1.00 molar acetic acid from a 17.5 molar stock solution of acetic acid? What volume of stock solution is required? So you know how much you want to make, and you know what concentration it's going to be. It's 1 molar, which is much less than 17.5 molar. How much of this super concentrated acid do you have to add to your water in order to end up with this much solution? That is what we are trying to figure out right now. Okay? So if I'm going to use this dilution calculation right here, I've got to find my M1, my V1, my M2, and my V2. I didn't say this up here, but these volumes are always in liters. Always, always. And the reason for that is because molarity is moles per liter, and we want the liters to cancel out with each other and get you the moles that you want. Okay, so you have to convert the volumes to liters no matter what if you're going to do this calculation. Now, so if I'm going to do a 500 milliliter solution, I need to convert that to liters. So 500, notice that decimal point there, milliliters, 1,000 milliliters in 1 liter gives us 0.500 liters. And then after that, I should be able to fill everything in. I want to prepare this right here. So think to yourself, am I starting with this or am I ending with this? These right here, even though they're listed first in the problem, are actually my M2 and my V2. So M2 is 1.00 molar. My V2 is 0.500 liters, as we just calculated. My M1, my initial concentration, is going to be this terribly large 17.5 molar. And my V1 is what I'm trying to figure out. I need to see how much of it I need to use in order to get this concentration over here. Then I can set up my formula. M1V1 equals M2V2. Truthfully, of course, it really doesn't matter which set you put as the ones and which set you put as the twos, because you solve them the same either way. And then I'm going to plug it in. So I have 17.5 molar times V1 equals, looked at the wrong thing there. 1.00 molar times 0.500 liters. And then I've got to solve. So I end up with 17.5 molar times V1 equals 0.500 moles. Because moles per liter cancels with liters to give you just moles. And then if I divide both sides by my 17.5 molar, I end up with 0.0286, and I have moles divided by moles per liter. So moles cancels with moles, and we are left with liters here. So that is how much of our concentrated acid we would need to combine with our water to end up with that much solution. And of course, when you look at this, 0.0286 liters doesn't tell you very much. So I'm going to go ahead and convert this to milliliters, because 28.6 milliliters is something much easier for us to go back and actually execute in the lab. So that was our first calculation right there. I want you to take a second, pause the video, and try the second one. It's also really, really straightforward. Okay, so I'm going to do this one exactly the same. I'm going to look at the problem. What volume of 12 molar HCl must be taken to prepare 0.75 liters of 0.25 molar hydrochloric acid. So I'm starting with 12 molar right here. So that means my initial molarity is 12 molar. My initial volume, how much of it? I don't know. That's what we're trying to figure out. My V2, my final volume is 0.75 liters, and my M2 is 0.25 molar. Plug it into my formula. 12 molar times V1. This ends up being exactly the same calculation. So probably not the best second problem, but you know you're about to get more. So then it ends up being V1 equals 0.016 liters or 16 milliliters. Oops, sorry. And of course, this is not necessary in milliliters, but realistically, it's preferred.